Welcome back to Liz Maths tutorial. Today we are going to learn the three examples which comes under in arithmetic progression. So we have connected to the last video. I am taking these three examples. In my last video I have explained the examples how to find the nth term of an AP. So those have not watched that video, watch it and come back to this video. So here today we are going to solve the three examples. So let us start with the first example. Now let us see this example. What this example says. Check whether 301 is a term of the list of these numbers. Whether 301 is a term of this list of numbers. The list of numbers are given. They have not mentioned it whether it is an AP. So first we have to check whether this is an AP. So after finding, come to a conclusion that this is an AP, what we have to do next? Next we have to check whether this 301 is the term of this list of numbers. Whether this 301 will come in between of these numbers. Got it? There are numbers etc. In this what infinite arithmetic progression. So here you can whether you can find this 301 as a one of the term that we have to check it. So how to do this? Let us start the solution. See here, first what the list of numbers given? 5, 11, 17, 23 and so on. Here you have to find whether this list of numbers are in AP. So how to find out? You have to find the common difference of these numbers are same. So you have to find A2 minus A1 here. What is A2? A2 is 11 minus 7, that gives you 6 here. Then you have to go for A3 minus A2. A3 is 17 minus 11, that also gives you 6 as a common difference. Let's go for A4 minus A3. A4 is given as 23 minus 17 as A3. That also gives you the 6 as a common difference. Now we can find this all our common difference is same. So we can say that the given list of numbers are in AP. So here we don't know what are the continuation of this number. So we don't know. So I am going to take that there are continuation of numbers comes here. So what is the last term? How to represent it? We know that the last term we are representing it as nth term. But what is the next term? That is n plus 1th term, isn't it? Next goes an plus 2 coming, isn't it? So here representing this n as k I am representing here to find out. So what is the next term? What you can write as k plus 1, isn't it? So when we are going for the finding the numbers, n numbers we don't know what is the end of that number. That are infinite numbers, isn't it? So here this is an infinite arithmetic progression. So there are infinite numbers. So we are representing it as that is the ak plus 1 minus ak. If you do that also you will get the difference is the same as 6 only. So here we can come to this as ak plus 1 minus ak. K plus 1 minus ak is same for all k is equal to 1, 2, 3. So therefore the list of numbers are in AP. So we have come to the conclusion that the list of the numbers are in AP. So after you are finding this list of numbers are in AP, what you have to find out whether 301 is a term of that. Got it? So here you know that the first term is nothing but the first term is A that gives you the 5, and what is the common difference you can see here? D is equal to 6. D you are finding, D is this, and what is the nth term? See here, check whether 301 is a term. That term in which place we don't know. See here, for example, if you say A1 means that is the first term, A2 means that is 11. A2. That is the place value of that 11 is A2. Then A3 is 17. A4 is 23. So likewise, we don't know what is that A term, that is AN, that we don't know. So here you can say A4 is nothing but 23. But here you don't know A for which you are getting 301. Got it? For A, which one you are getting 301, we don't know. So what we have to do, we have to write in the place of that we don't know, we are writing it as N. Got it? So that AN term is we are taking 301. Okay? I hope you understood. Now, which is that AN is 301. Now use the formula to find out what is that N. What is the formula? AN is equal to A plus N minus 1 into B. What is AN? AN is 301 we are taking, and A is 5 plus N you don't know, so write as it is N minus 1 into D is 6. Now here you go for simplifying this. See here 5 plus, go for the multiplication because inside the bracket N minus 1 you can't do anything with that. So here you go for multiplication, 6N minus 6. Now you simplify here, that you will get here 6N minus 1, here 301. Take this 301, this minus 1 to this side, so you will get 301 minus 1 this side get comes, that you will get plus 1, then you will get 302 here, then 302 is equal to 6N. So now N is equal to what? N you have to find out. So bring the 6 here down. So when here multiplication, this side comes, it's division. So here 6, 2, 3 are 6, and here 2 1s are 2, then 1 is remaining. Here 10, 2 5s are 10, then again 2 is there, 2 1s are 2. So what you will get, therefore N is equal to 151 divided by 3. See what you got here, N is equal to 151 by 3. So here what you have to think about, what the N you got, whether it is a positive integer. See here, the given list of numbers you can see 5, 11, 17, 23. These are the positive integers, isn't it? Can you find anything other than positive integer here? No. These all are positive integer. So, but what the N we got here, it is not in the form of positive integer. We can come to the conclusion that this 301 is not a term of the list of this number. Got it? So here we can write its conclusion. So you have to write the conclusion here. N is equal to 151 by 3 is not a positive integer. Therefore, what do you have to say? Therefore, 301 is not a term of the list of given numbers. So this is a conclusion you have to write it. So how you have to do? First you have to check whether the given list of numbers are in AP. Next you have to find out 301 is a term or not using this formula. Got it? Okay. Now we move on to the next example. Now here the second question says, how many 2-digit numbers are divisible by 3? See, they have given only the hint, like you have to take the 2-digit numbers are divisible by 3. How you can write the 2-digit numbers? See, when you go for the table 3 here, see for 3 is a 9 you are getting, isn't it? But 3 4s are 12. 3 5s are 15, isn't it? Okay, 3 5s are 15. Then 3 6s are so on, 18. So on you are getting, isn't it? See, that when you go for the 2-digit numbers, what you can find here? Here, if you go for 3, how much, sir? That last number you are getting. See here, you know that the last number, if you go for the 2 digit, is 99 is the last number. When you say the 2 digit number beginning with 10, isn't it? Till the last number is 99. So when it comes to 99 here, whether it is divisible by 3, that you have to check it. You know that it's divisible by 3. 3s are 9 and again 3 3s are 9. So 33s are, you are getting this 99. Am I right? Yes. So you can see the numbers which are coming here, the 2 digit numbers are 12, 15, 18, so on up to 99. You know that the 100 number, after 100 there are 3 digit numbers, isn't it? So here up to 2 digit number you want, because here clearly given how many 2 digit numbers you have to find out. Here I have written in between so on, that so on is how much we don't know. Here you can see only the 4, here 3 number and here 1 number. And in between there are numbers that can divisible by 3, but we don't know how many are there. So how to find out how many 2 digits numbers are divisible by 3? So now first we can list out these numbers using this. See here, the list of 2 digit numbers divisible by 3 are, you can write, that is 12, 15, 18, so on up to the last number is 99. Got it? So here you can write this. Now you have to check whether this is an AP first. Okay, how to find out the same AP? You have to go for the finding the difference. A2 minus A1. A2 is 15 minus 12. You are getting 3. Again you go for A3 minus A2. That is 18 minus 15. Then you also here also you are getting the common difference is 3. So you can come to that the common difference is D. D is equal to 3. And here the first term A is equal to 12. Now this much you got, isn't it? Now how to find out the how many digits are there? Here you know that the last term is given. 99 is the last term. Last term, here we can say, how we can say this is the last number? That the 2 digits numbers are up to 99 only, isn't it? After 99 you are getting 100. So 100 is not a 2 digit number. So till 99 you are getting. That 99 is comes here, isn't it? So we can say that this 99 is the last number. So we can write that as the last number, that is nothing but nth term is 99. We don't know what is n here, isn't it? We have to find out n here because we want to find out how many 2 digits numbers are there. We know that 99 is the last number. That's why we are taking here that last number as n, because we don't know how many term, which term, that the place value of that 99 we don't know. Got it? The place value of this is 1, this is A2, this is A3. So we don't know what is the place value of 99 because there are numbers in between this. So we don't know what is the 99th term place value. So we are writing it here. N is equal to An is equal to 99. So now use the formula here and find out what is that n. So which is the formula? N is equal to A plus n minus 1 into D. Now substitute An is equal to 99 here. N is equal to 99 is equal to A means 12 plus you don't know n. You write n minus 1 as it is and write the difference is 3. Now go for simplifying this. 99 is equal to 12. Now multiply this 3n minus 3. Now 12 minus 3 here. What do you get? Write 99. 12 minus 3. What do you get? 9. then plus 3n. Bring this 9 to this side, so you will get 99 minus 9 is equal to 3n. So 99 9 goes, you will get 90 is equal to 3n. So what is n? N is equal to 90 by 3. So 3 how much are? 3. 3 is a 9, so 0. So n is equal to 30. So how many 2 digits numbers are divisible by 3? 30 numbers are 30 2 digits numbers are there that are divisible by 3. So we can write the conclusion. Therefore there are 30 2-digit numbers divisible by 3. So this is a conclusion that we come. There are how many? 30 2-digit numbers divisible by 3. So this way you can find out the divisibility by 2 or any other numbers, you can do it. Got it? So you have to check. How to check? First you have to check whether in a table in 2-digit or 3-digit or anything, you can check with using this step method. I hope you understood. Now move on to the last example here. Now we can see here the last example. See, this example is little tricky. See here, find the 11th term from the last term. In the bracket they have given towards the first term of the AP. The AP is given here. See, now what you have to do here, you have to find the 11th term from the last term. The nth term, that is the last term they have given here. When they give the last term, I've told you in the previous video that when they give the last term, you have to use which formula here? L minus n minus 1 into d. When they give the last term, you have to use this formula here. So here, how to find out the solution? See, first you know that given AP is nothing but 10, 7, 4 up to minus 62. Can you see here? Minus 62. This is minus 62. So here you can see that this minus 62 says that last term towards the first term. See here, if you can write, this is in a reverse way also, if you write, and you can find out in using the formula, and you can do it. So here what is given? The first term A is equal to 10. Now go for finding the difference D. D is nothing but 7 minus 10, that gives you minus 3, and 4 minus 7, that also gives you minus 3. So D is minus 3, and the last term they have given, that is, I've told you, L is equal to minus 62 they have given. To find out that the 11th term from the last term. So how to find out that last nth term? Therefore the last nth term, which is the formula I've told you, L minus n minus 1 into d here. So this is a formula we have to use here when they give the last term. Got it? So now substitute. What is L? L is minus 62 minus, and what is n? What is n? See here, what is n here? So I have not written here. What is the 11th term? That is the n. 11th term. N is equal to 11 here. The 11th term. So 11 minus 1 into d. D is what? Minus 3 here. So here minus 62. Open the bracket here, minus 11 minus 1, you will get 10. So open the bracket, you will get here 10 into minus 3 here get. So now go for which is first, multiplication is first. So minus 62 minus 10 into minus 3, minus into minus, you get plus 30. Isn't it? Now go for this subtraction here, minus 62 plus 30. Both are different signs, so you go for the subtraction. So what you will get here? Minus 32. So you can come to the conclusion that therefore the 11th term from the last term is minus 30. Therefore, the 11th term from the last term is minus 32. I hope you understood this problem. So, I am going to wind up my today's class here. See, if you want to find out these types of problem, you can go to exercise 1.2. There you can find there are similar to this type of problems. So, I hope you understood today's class. Those who have not subscribed my channel, subscribe it, and there is a bell icon next to that. Enable that. That gives you a notification regarding my new upload videos. Hope you are fine. Have a nice day.